Hello everyone, welcome to the another lecture of Haloalkanes and Haloarenes. Myself, Suman Singh. So as we know, we in the last class we have discussed about the Darjan's method, right? So today we are going to discuss about the Borodin-Hundsdorfer reaction. Okay. So when we talk about this Borodin-Hundsdorfer reaction, I will tell you a simple tricks from where you can easily identify that this is a Borodin-Hundsdorfer reaction, right? Suppose we are given here like this, or there's COOAG, okay, and if here we are given Br and Br, so what will be the product? Product will be like this will react with this, and this will react with this, and this one will go out, since this is what if we have learned about this in class 11 parrots of chemistry, right? So this will, what it will do, it will fly out, right? The CO2 will fly out, and what will be our product? The product will be our RBr, okay, plus AGBr plus CO2. This will come out, right? So this type of reaction is called what? Hundsdorfer, Borodin-Hundsdorfer reaction. So how about how we can define this? So if we want to define this, we can define like this, that bromoalkene can be easily prepared by heating silver or lead salt of an acid with Br2 in presence of CCl4, okay? So this bromonative decarbolization is called what? Borodin-Hundsdorfer reaction, okay? So I will give one more example, right? So one more example you can take like this. Suppose we have like this a benzene ring, okay? In this benzene ring, suppose here we are attached with COOAG, okay? COOAG, and suppose this is our here like this, okay? So what will happen if we are supplying here Br2, okay, Br2, and so what will happen? The intermediate will form like this, right? The intermediate will be like this, okay? Intermediate will be like this, right? And the next product we will get what? Product will be, we will get like this, right? Here CS3, right? And here we will get what? Br, right? So this type of reaction is called what? Borodin-Hundsdorfer reaction. Here two product will form, one is this and another one will be this, okay? Another one will be this, this one will be as it is, okay? And this one will be like this, here Br, okay? So this is called what? This is what? Borodin-Hundsdorfer reaction, okay? So we will see the mechanism, okay? So when we talk about the mechanism of this Borodin-Hundsdorfer reaction, we can write like this. Suppose we have this, okay, R C O minus Ag plus, okay, Ag, sorry, Ag plus, okay, plus suppose we have Br2. So what will be the product? The product will be like this, R C O Br, okay, RCOO okay, plus AgBr, okay? So when we will see the number, this one is suppose number 1 and number 2 is this, okay? And this one in number 2 is this. Now what will happen? This Br, since here when we talk about this number 2, product number 2, so if I am writing here product number 2, suppose here is COO Br, okay? So since this oxygen is carrying a lone pair, right, and this bromine is also having a lone pair, then these two bond will be weak, right? And what will happen after some time? This bond will break, okay? And when this bond will break, it will form like this, RCOO, right? Here it is, okay, like this, and or we can write like this, okay, and plus, sorry, plus we will get Br radical, okay? This is a radical sign, okay? RCOO radical and Br radical we will get. So this one is now suppose number 3. Okay. Now after what will happen here, this there will be a shift when we are talking about this R uh, COO radical, it will break to form R, okay, radical, plus CO2 will come out from the reaction. Okay, CO2 will come out from the reaction. So how it has this bond is broke, we can, I will write here. You can suppose this is R, this is C, here double bond O, okay, and here is O. Since it is carrying a lone pair here, or it is a radical here, one electron is here, right? One electron is here, and this one is also carrying an electron here, and one electron is here, right? So what will happen, this electron will shift here, okay, and the electron which is present here, it will shift here, and in this way what will happen is will form this R, and this CO2 will come out here. I hope you have understood this, right? So now we have got what, R radical and CO2, here CO2, right? So now what will happen, this R radical, what will do, what it will do, it will again react with that number 2 product, this one, okay, it will react with this, okay, plus R R C O O B R, and the final product will be, we will get the final product here as R B R plus R C O O radical, right? So again this one will all, and this one will further carry out the reaction in the same way, right? So this was all about the mechanism of Borodin-Hunsdrucker reaction. I hope you have understood this, right? So this was about the Borodin-Hunsdrucker reaction. One example I will show you. Suppose we have a product like this. Here is we have COOAG, and here also COOAG, okay. And suppose if we are supplying here Br, okay, and heat, suppose we are supplying here Br and heat, what it will form, it will always form one intermediate. You can see like this, one intermediate will be like this, okay, here one radical, one, and here one, okay, and the final product will be major product, which we will get, which we will see, the major product will be alkene, okay, this one like this, okay. So this is what, this is also an example of Borodin Hunsdrucker reaction, okay. One more thing what you can see, one more example I will give you. If suppose we have like this Me, okay, here COOH, okay, and now in presence of Ag2O2, okay, plus here if we are supplying here Br2 or CCl4, okay, here we are supplying here Br2 and CCl4, okay, then what will be the product I am writing here, right? Product will be like this, right? In place of COOH, what will come, Br will come, okay. So it will be like this, Me plus Br will come here, and it will become what, CO2 plus AgBr, right? So I hope you have understood what is Borodin-Hunsdrucker reaction. As you can see, it is also written here, alkyl chloride or alkyl bromide are prepared by the action of Cl2 or Br2 in CCl4 of silver water fatty acid. As you can see, example is also given here, right? So I hope you have understood what is Borodin-Hunsdrucker reaction, right? Now next we will see by halide exchange method, okay. So when we talk about the halide exchange method, okay, here basically we are learning about Finkelstein reaction, okay. So halide, when we talk about the halide exchange method, what we will basically, what we are saying, we are seeing the iodination, okay. So iodination is what, iodination of alkene is generally taking place here, okay. As we know that iodination of alkene is generally not carried out to prepare alkyl iodide, right? So since this reaction is very highly endothermic, okay, so endothermic, but carried out by then that is why this reaction is carried out by Finkelstein reaction, okay. As we know that iodine is a what, it is a better nucleophile, right, and a better leaving group also. So what we will do in Finkelstein reaction, what is happening, you see, suppose if we have as you can see here, if we have RCl or RBr in presence of NaI and acetone. If it's a heat is providing, if we are providing heat, then what will happen? This Ri, it will form Ri, and NaCl will come out. And this, always remember that this NaCl and this NaBr, why it is not going in a reverse reaction? Because this NaCl and NaBr will form as a PPT. Okay, it will precipitate in the tube, right? That is why it is not going a reverse reaction. So in this reaction, as you can say, RCl and RBr is reacted with NaI in presence of acetone to give Ri and NaCl, or Ri and plus NaBr. And since this Ri and NaBr and NaCl is in the form of PPT, okay, so that is why it is not going in a reverse reaction. Okay, now next, what if you are asked to form what are the two basic concept of this reaction? The two basic concept is NaBr or NaCl will form PPT. Okay, it will not go reverse in the reaction, right? And the second one is reaction is SN2. Okay, and this reaction is what? The second thing is what? This reaction is SN2 reaction. Okay, and there will be an inversion in configuration. Okay, I will tell you, I will say, let me tell you the mechanism how it is happening. Suppose we have here this RCl. Okay, we will talk about this. It is written clearly, right? Now we will see here. Okay, so this is an RCl. Okay, so what will happen in the first step? What will happen? This we are taking what? NaI, right? We are taking here NaI. So this NaI is means what? Na positive, right? And I negative, right? So this I negative, what will come, what it will do, it will come and it will react from the backside to this R, and when it will react to the backside to R, this chlorine will come out from the reaction. This is what? This is a type of SN2 type, right? So it will form RNA, Ri, and the C and the Cl negative, which will form after this Cl negative, which will come out from here. What it will do, it will react with this. Since it is a negative, it will react with this Na, and it will form NaCl, as you can see here, right? So here what is happening? It is just what it is happening, it is just an SN2 type, right? It is attacking from the back side. This nucleophile is attacking from the back side, and this chlorine is coming out from here. Okay, and at that time we are getting what? Rai, and this Cl negative and this Na positive is further reacting to form NaCl. Okay, so this is the type of SN2 reaction. Okay, and how it is, the one more thing I have told you, right? And there will be an inversion in configuration. So how the inversion will take place? As you can see, I will give you one example for inversion. Suppose we have this, here we have Cl, here we have T, here we have, suppose, D. I hope you can see, right? Or let me change the color. Suppose we have here Cl here, okay, and here is T, okay, and here is D, and here is H. Suppose if we are talking about, then if this one is 4, this one is number 4, and this one 1 2 3 4, like this. Okay, so suppose this was at that time, this was R. Okay, so when this NaI, when we are taking this NaI, and if NaI is, what it will do, it will react, it will come and attack here, right? It will come and attack from here to here, right? So when it will attack here, this chlorine will come out, right? When this chlorine will come out, it will form like this, it will form like this, right? Here it is D, here it is T, here it is I, okay, and here it is H, right? So at that time it became S. Okay, when if it, suppose it was R, at that time it will become S, and now you can see there is an inversion in configuration, right? So that is why when we talk about the halide exchange method or iodination, so as we know that iodination of alkene is generally not carried out to prepare alkyl iodide. So in this way, because it is very highly endothermic reaction, that is why we are using this with the help of Finkelstein reaction. So in Finkelstein reaction, basically what is happening, we are, it is a, here NaCl and NaBr is formed as a PPT. Okay, and the reaction is SN2, as you have seen, the reaction is SN2, right? And there will be an inversion in configuration. Okay, I hope you have understood this. Now one more thing, one more example, if you want to take, I can give you one more example. Suppose we have like this. Okay, suppose we have like this. Suppose here we have Br. Okay, so when if we are giving here NaI, so what it will form, it will form like this. Okay, it will form like this, and here iodine will come, right? I hope you have understood this, right? So this was all about the borrowed, and this was all about halide exchange method, from the halide exchange method. Okay, now next we will see uh, Schwartz reaction. Okay, so when we talk about the Schwartz reaction, let me write here, um, SWARTS. Okay, Schwartz reaction. So when we talk about the Schwartz reaction is what? It is the best way to prepare alkyl fluoride. Okay, alkyl fluoride, and from what we can say, it's the best way to prepare alkyl chloride. Okay, from alkyl chloride or alkyl bromide. What we are doing here, we are what basically what we are doing here, we are heating this alkyl chloride or alkyl bromide in the presence of metallic fluoride, right? Such as AgF, or such as AgF, okay, or Hg2F2, or COF3, okay, or SBF3. So this Schwartz reaction is, always remember that this Schwartz reaction is the best way to prepare alkyl fluoride. Okay, and what we are doing here, we are basically, we are heating, we are heating this alkyl, we are heating alkyl chloride and alkyl bromide in presence of this AgF or Hg2F2 or COF3 or SbF3. Okay, so this is what this is called Schwartz reaction. What is happening here, I will give you one example here. In Schwartz reaction, we are talking about Schwartz reaction. Suppose we have CS3 here, CS3, CH2, Br, okay, and in here if we are using AgF, so what will happen, in place of bromine, this fluorine will come. Okay, it will be like this, CH3, CH2, and F plus AgBr will come out from the reaction. Okay, I hope you are understanding this, right? Now next is, if we are taking one more example, suppose we are taking this example. Let me give you one more example. Suppose we are taking this example. Okay, so here also what will happen, in presence of AgF, what it will form, in place of bromine, this fluorine will come. Okay, in place of bromine, this fluorine will come, and AgBr will come out from the reaction, right? So this is the Schwartz reaction, and it's the best method to prepare uh, alkyl fluoride. Okay, so from this method only, first time we have prepared Teflon. Okay, Teflon was first prepared by this method only. Okay, so I hope you have understood about the Schwartz reaction. Now next we will see from aldehyde and ketone. Okay, so when we talk about the preparation from aldehyde and ketone, I will give you one basic simple example. Suppose we have this um, double bond over this. Okay, and if we are supplying here three type of reagent. Okay, in one case, if we are supplying here PCl3, in this case if we are supplying here PCl5, okay, and if here SOCl2, in both the three cases the product will be same, which is this. Okay, here Cl and here Cl. Okay, so this is all about some how this alkyl halide is prepared from aldehyde and ketone. Okay, I will give you one basic example for that also. I can give you an example. So example is, suppose we have R C H double bond O, and in presence of PCl5, what it will form, what I have told you, it will form R, it will form what, R C H Cl2 plus POCl3, right? Again, if you are taking here R COR in presence of PCl5, it will form what, it will form R dash CCl2, okay, CCl2 dash R, okay, plus POCl3. So in this way we used to prepare alkyl halide from aldehyde and ketone. Okay, so I hope you have understood this, right? So now next is what, Sandmeyer reaction. Okay, we will see, let me find where it is. we will see Sandmeyer reaction is here, this one Sandmeyer reaction. Okay, so when we talk about the Sandmeyer reaction, so always remember that when we talk about the Sandmeyer reaction, suppose we have this R, there's NH2. Okay, let me change the color. Suppose we have this R, okay, and NH2. So what we are doing, we are just supplying here HNO2. Okay, we are supplying here H, we are supplying here HNO. Oh, sorry. Suppose we have R, okay, and NH2, and suppose we are supplying here what, HNO2. Okay, so as we know that HNO2 we can't supply directly, so to get HNO2, what we are using, NO2 plus HCl. Okay, because we can't supply HNO2, right? So what will happen after this, when we will supply HNO2, at that time it will form what, it will form like this, R N2 plus. Okay, so as we know, this is what, this is a super leaving group, right? Now after that, what will happen, if we are supplying here, suppose if we are supplying here, suppose let me write here. Okay, what we have got, R NH2, from R NH2 in presence of HNO2, in presence of HNO2, what we have got, we have got R dash N2 plus, right? So now what will happen, if we will supply here Cu2, suppose this is R, we have got this, right, N plus 2. Now if we are supplying here what, Cu2x2 or Hx, at that time what it will form, it will form Rx. Okay, since this one was what, this is a very super looping group, this will leave, right, this will leave very easily, and in place of this X will come and attack. Okay, so this X can be anything, it can be chloride or bromide. Okay, now next, as you can see, one more example is given here. As you can see this example. Okay, here what we have used, here NH2, we have used NH2, right? So in presence of HNO2 and HCl. Okay, so what is happening, the reaction is very you can see 273 means 5 degrees Celsius, it is happening in 5 to 7 degrees Celsius. Okay, so as you can see here, what it will form, N2 plus and plus Cl will come out, right? Now after that, what will happen, this Cl, which the halide which will form here, it will be like this, the Cl will come here, as you can see here, right? In that case I have explained, right? So Cl will come here, as you can see. So this type of reaction is called what, this is called what, benzene diazonium halide, right? This is benzene diazonium halide, right? So after that, what will happen, in benzene diazonium in this benzene diazonium chloride, okay, or halide, anything, what will happen next, what we will do, we will use here Cu2x, okay, or CuCl, anything. Okay, so when this is benzene diazonium chloride, we have got benzene diazonium chloride. Now again, what we will do, in benzene diazonium chloride, like this, in this benzene diazonium chloride, we will use here, suppose we have N2 plus and Cl minus, right? So we will use here, suppose Cu2x, at that time what we will get, we will get this. Okay, we will get this Cl here, okay, chloride and plus N2 will come out from the reaction. Okay, since it is what called, it is called parrots of chemistry, which it will flew out, right, it will fly from the reaction. So this type of reaction is called what, this type of reaction is called Sandmeyer reaction. As you can see, as it is, in the first case, aniline we have used, aniline has formed what, benzene diazonium chloride. After that, what we have used, CuCl. So in presence of CuCl, we have got what, this and this, and if we are using here bromine, at that time we will get this and this. Okay, So I hope we have understood this alkyl halide, aryl halide, how and what is this Sandmeyer reaction, right? So after that, if you are next we will see from ester, okay, ether, sorry. If you will see from ether how this it is prepared from ether, okay, it's given, no, okay, it's not given here. So we will see here from ether, if we are talking about from ether. So suppose we have this R O R, right? So what will happen if we are using here PCl5, okay? If we are using here PCl5, at that time what it will form, it will form R2Cl plus POCl3 will come out from here, okay? In the same way, what is in the same way we can see one more example, R dash OR, okay? And if we are using here HI or cold, okay, at the time what it will form, it will form ROH plus RI, okay? So I hope you have understood this, right? So keep up to this. In the next class we will see Gattermann reaction, okay, and its chemical property, okay. Till that, thank you.